Hello students, today we are going to study in a very brief way the role of plastics in modern life. As we all know that plastic, which is a common synonym for the more technical word polymer, has been in use since the beginning of time. The word plastic is mainly derived from the Greek word plastikos, meaning something which can be molded and shaped, which can be heated and shaped. That is the meaning of plastikos, from which the word plastic has been derived. If we look around, we will find that in today's world, this plastic is in use in diverse fields. If we just look around, we will find that plastic is used as a material in housewares, in textiles, in foams, in medical devices, in protective shields, in industries, in material components like ball bearings. Medical appliances include biomedical devices also, and housewares include so many diverse things used in our domestic sectors. This polymer or plastic has got some special properties if we compare them with those of metals. We would observe that plastics are generally having lower stiffness, lower strength compared to the metals. Moreover, they are having lower electrical and thermal conductivity if we compare them with the metals. They do have a temperature range over which they are stable, which is up to 350 degrees Celsius, which is lower compared with those of metals. The plastics do have a very important advantage if we compare them with those of metals. That is, they can be very readily molded or cast or joined with relative ease into very complex shapes and can be machined without or almost with little necessity for surface finishing operations. This is a very definite advantage which we can claim the plastics to possess when compared with metals. From the foregoing very brief discussion, it may appear to you students that plastics is the material of choice or is an unmixed blessing in modern day life, but that is not so, because plastics are posing serious environmental hazards in today's world. I can tell you very recent facts, some very recent facts about the plastic pollution. The plastics that we use, 5% of them is actually recyclable. That means we are presently able to recycle or reuse 5% of the plastics that we use. 50% of the plastics that we use are thrown just after single use. And the most troublesome fact is that the plastics take 500 to 1,000 years to degrade, meaning that the plastics which were once created, the modern plastics, began its journey in somewhere around 1850, and from then all those plastics are in nature in some form or the other. They haven't been degraded till today. Another very important aspect is that the plastics are produced, many plastics are produced from petroleum, natural petroleum, and 8% of the world oil production is being utilized in production of plastics. That is also a very important fact, keeping in view the diminishing reserve of these fossil oils. And last but not the least, its effect on the sea and marine life has been devastating. It has been estimated recently that 1 million seabirds die every year due to ingestion of plastics. Plastics have been found in their stomachs and intestines, and also perforations of the intestines have taken place due to ingestion of plastics. And 1 million mammals, sea mammals, die due to the consumption of plastics annually. This is a very disturbing fact which can never be ignored. So these are the pollution aspects that we must consider when, after today, we will be going to a slide show. When the slide show will be over, we will look at these merits and demerits of the plastics once more, if time permits, and then we will try to conclude something. Okay, let us go for this slide show. In the first slide that you observe, polymers are extremely important materials. We have been using polymeric materials in our daily life. So that has been already said in my introductory lecture. And this cellulose, wood, rubber, etc., these things have been in use since time began. Without the knowledge of these polymers or big molecules, macromolecules as it is known today technically, the ancient people didn't know that they were macromolecules, but they are in use. And biopolymers, these proteins, enzymes, DNA, they are also big molecules, and they are in existence, as we all know, from the beginning of time. And this last 50 or 60 years, the things I have just talked about, these biomedical devices, nowadays, the heart valves and arteries, they are being made up of plastics, making possible very complicated heart operations. So this is the tremendous advances that we have been witnessing for the last 50 years. So, in a word, polymer has been engulfing our life. These polymers, as it is known, poly means many and mar units. So monomers are the basic units making up the polymer, and they are repeatedly joined to form a big molecule called a polymer. And this process of making a polymer from a monomer, or the very joining process itself, in which the monomers are getting added to form a polymer, is called a polymerization. If we observe this figure in which this ethylene molecule is getting converted to polyethylene by the application of heat, pressure and catalyst, this is a description of how this polymerization, the process of joining together many small molecules, take place
as you see this in the ethylene molecule, which is the monomer, carbon has double bond, and the double bond is broken due to the application of heat and pressure and catalyst, forming single bonds, and they go on at being added up to form a polyethylene, which is one of the most widely used materials today for containers, for beverages or foods and packagings. Polyethylene. So MAR unit composed 2 carbon and 4 hydrogen atoms, as you can see. These joining of monomers need not be from the same type of monomer. They need not be alike. So 2 different monomers can polymerize themselves to give a polymer, and this, when 2 monomers get added up, we call them copolymers, and when 3 monomers get added up, we say that the polymer resulting is star polymer. So these are the one of the very basic sciences, the copolymerization, that is polymerization brought about by 2 different functional groups. And there are certain types in which these monomers arrange themselves during the polymerization. When 2 monomers A and B are randomly positioned, such as in styrene butadiene rubber, they are randomly positioned. They are called random copolymers. The styrene butadiene rubber, as we all know, is the rubber used in tires today, and a very useful material, styrene butadiene, and styrene is one monomer and butadiene is another monomer. Alternating copolymers are there in which A and B alternately get the position. They alternate AB, AB, AB. Nylon 66 is the material. Hexamethyl diamine and adipic acid, these 2 monomers get added up and they alternate in the polymer chain to form this nylon 66, which is used in textiles, in socks, in cords, in climbing ropes, etc. In block polymers, when 2 clusters of polymers are getting added up, we form block copolymers. There may be 2 clusters, there may be 3 clusters. One very common example is you see when 2 polymers are there, then suppose 4A and 4B are joined together, so it's a block copolymer consisting of 2 monomers. There may be 3 monomers added up, which we call tar polymer. One very common example is acrino butadiene styrene rubber, ABS rubber, which is the not rubber, it is a tar polymer basically used in the shields, protective shields like helmets. Acrylonitrile butadiene styrene, popularly known as ABS. And graft polymer is another copolymer in which a side chain having more flexibility is joined with the main chain, and the popular example is high impact polystyrene. Polymerization, when viewed from the mode of synthesis, can be divided in 2 types: addition polymerization and condensation polymerization. In addition polymerization, monomers just get added up without the formation of any reaction products. And we have already talked about polyethylene. This is one addition reaction product. In condensation polymerization, the generally two types of monomers get added up with the formation of some reaction products in the form of water or alcohol, etc. Addition polymerization is generally brought about by the addition of heat, pressure, light and a catalyst, and they take place very quickly in seconds, whereas in condensation polymerization the reaction takes place for hours or even for a day. Nylon 66, of which we have talked about, is one of the condensation polymerization product, and another very popular product is bakelite, formed out of phenol and formaldehyde. The size of the polymer molecule is decided by the number of repeat units present in it. The number of units repeated in the chain is called the degree of polymerization, and gives an idea how big the molecule is. The polymers can also be divided according to the source from which they are derived. Natural polymers, as we have seen, cotton, silk, wool, rubber, they are in use, and they are called natural polymers because they are derived from natural sources. They are not synthetically produced or synthetics as we know them today. And synthetic polymers, they are generally laboratory made or man-made from certain natural products, of course, polyethylene, nylon, PVC, terylene. And it is worth mentioning that this nylon, PVC, these things are generally derived from natural petroleum. The source is natural, but they are processed, synthesized in laboratory, so they are called synthetic polymers. Depending on whether there are carbon atoms in the backbone chain or not, we can divide them into organic polymers or inorganic polymers. In organic polymers, there are carbon chains in the backbone, and in inorganic polymers, there is no carbon atom in the backbone. All the synthetic polymers or synthetics or synthetic fibers, they are grouped under organic polymers. And inorganic polymers include glass, silicone, and the modern substitute for natural rubber. They are all, and also the natural rubber, they are inorganic polymers. And lastly, we can divide the polymers in two groups. This thermosetting and thermoplastic. First, let us deal with thermoplastic, which those which soften on heating and then harden again on cooling are called thermoplastic. These thermoplastic polymers are those materials in which the Mar units are joined by covalent bond, but the chains formed by this addition are joined by very weak forces. They are not at all joined by very strong forces. The weak forces like van der Waals bond or hydrogen bond, etc. So when we apply some heat, that bond is broken and they can be reshaped, remolded and reshaped as we desire them. Some examples: acrylics, celluloids, nylon, polyethylene. Thermosetting plastics or polymers are those in which the chains are cross-linked by very strong bonds, generally covalent bonds, and due to this cross-linking, they cannot be easily remolded when heated. When heated, they do not get melted easily. When we apply extreme heat, they can char. They can char, but they are not at all melted, and when extremity is applied, they char and become degraded. They maintain their dimensional stability well when compared to the thermoplastic, and these thermoplastic materials are like you see this phenol formaldehyde, bakelite. These are thermosetting plastics, and these thermosetting plastics may be thought to be more desirable from dimensional stability, but thermoplastics are also preferred in certain situations when formability is of utmost importance and mechanical strength is secondary to this formability. In those circumstances, thermoplastic is desired, in which we desire some complicated shaped object to be prepared out of these polymers. So these are all about the slide show.
From the foregoing discussion today, although very brief, we are now in a position to look back at the merits and demerits of the plastics. If we look at the merits of the plastics, then it is no doubt that plastics have been replacing our traditional materials in every field, in every walk of life today. But if we look at the pollution level that we have been suggesting in our introductory discussion, we cannot ignore the pollution aspect. This pollution or solid wastes arising out of the plastics should be controlled with all efforts from the government as well as from the mass level. There are 4 steps: the reduction at the source, incineration, and landfilling and recycling the plastics. These are the 4 measures generally resorted to. Mankind has been growing from the Stone Age through the Bronze Age to the Iron Age, Steel Age, to this Polymer Age, in which polymer is being used in construction material also, which is eco-neutral. What is to say eco-neutral? They are not posing any hazard to the soil. So they are replacing the traditional construction material also. So it is undeniable that this is going to be a polymer age. There can be no doubt in it. So let us welcome this polymer age with the warning that we should be aware at every possible national level to minimize the pollution of plastics. So in the conclusion, let us welcome this new age, this polymer age, and thank you.